All right, guys, so here is 4, so undetermined coefficients, and this is one method or one approach, superposition approach. The other method is in 4.5, but we are not doing that. So it's up to you. If you want to use that other approach, that's fine, but it's not necessary. I'm not testing you on that. Okay, so one of the big differences here is if you're looking at this function, it still is the same. You still have the same setup where you have the undetermined coefficients in front, like a sub n is a coefficient. But it's equal to a function of x. So couple things when you're solving these, right? One, you're going to find something of like y of c, we'll call it. And this is the homogeneous differential where it's set to 0. Okay, so this is like what we still have done over and over again in previous sections, like in the last section. And the second one is what we're going to do where it's then now equal to that function. Okay, but we'll have to do that. This is what is new. This we have already done. This is the new part, okay? All right, so let's do an example so you can see what I mean, and then I'll let you know, like, when you see these certain types of functions, how do you set this up for y sub p? So here's example 1. Okay, so here, so first step is still, you do the same thing. Set this to 0. So as if it was homogeneous. And then we solve normally. So again, we just go back to that last section where you're solving this quadratic. And here we're going to get so we get m to be -2 plus or minus root 6. Okay. One thing that I like about this question that we have, if you notice, there's no I in our answer. So we get for y of c, the homogeneous solution, we would just get c1e to the -2 plus root 6x, and then plus c2e to the -2 minus now root 6x. So because you don't have an imaginary or complex solution, right, you don't need sine or cosine in this situation. So that's the first part, but that's review, okay? Part 2, okay, part 2, because g of x, right, is quadratic, 2x squared, okay, because it's quadratic, then we start with saying, okay, y sub p is going to be in the standard form of a quadratic equation, which would look like this: ax squared plus bx plus c. And then what we're going to do is we're going to take the derivative and second derivative of each of these, and rewrite the differential that we got. So what I'm going to get here is 2a plus 4 times So all I'm doing is plugging everything in. And simplify or rearrange just so that you have it in a correct order. All right, we would have a plus 8a minus 2b, and I'm just going to write it this way, x, and then the constants plus 2a minus, or plus 4b minus 2c. Now, the reason why I'm doing that, all right, if you go back to what g of x was, which was 2x squared minus 3x plus 6, take a look at the coefficients. Okay, I'm going to set those equals. 2a has to equal 2. 8a minus 2b has to equal negative 3. And 2a plus 4b minus 2c equals a positive 6. Okay, and now you have, right, 3 equations, 3 unknowns, and you just have to solve for each of them. So here, a is going to be a negative 1. B is going to equal negative 5/2. And C winds up being negative 9. All right. So once you get that, then what we're going to do is plug it back into what we made y sub p, which really means a particular solution. So here we have negative x squared minus 5/2 x minus 9. And the final step in this problem is to put both types of equations together. So you're going to have y equals y of c plus y sub p. So it looks like you go back to what we had for y of c, which was up here, right? You can see that there. So we have c1 e to the negative 2 plus root 6x plus c2 e to the negative 2 minus root 6x, and then add y sub p, which we get negative x squared minus 5/2 x minus 9. And this would be your your general solution.